back. In the previous introductory lesson on basic statistics, we learned about the types of data, measurement scales and types of statistical analysis. Before we delve into further, we should also understand fundamentals of probability and probability distributions. In this lesson we are going to learn about the basic probability concepts, which include independent events, mutually exclusive events, multiplication rules, permutations and combinations. And to understand all these, we should also know about the two important terms, that are, population and sample. To understand the terms population and sample, let us take this hypothetical example where we want to study whether all the customers of comfy chairs are satisfied with the delivery timeline of comfy chairs, or not. In this case our population is all the customers who have bought comfy chairs from Alex's shop since its sale started. To get this information, we can analyze the data of all the 3,000 customers. But it might not be cost effective and will need a lot of time. Probably some data might not be available. There is an alternate way to this. We can do a random sampling of the deliveries, and collect turnaround time data for only those selected few. This set of data, the subset of the population, is called a sample, and the turnaround time data for all the deliveries represent the population. Here are some representations which are used for population and sample. Capital N gives the size of the population, while small n denotes the size of the sample. The parameters are the numerical representations for the population. Population mean is denoted as mu and population variance is denoted as sigma square. The parameters which describe a sample are called statistic. Sample mean is denoted by x bar and sample variance is denoted by s square. So, to understand the typical turnaround time for comfy chairs, we can analyze and conclude from the sample data. We will discuss the concept of probability in brief here. Detailed study on probability can be done with the help of books as well as in our training on statistics. Probability of an event describes the chance of occurrence of that event. Probability value can lie between 0 and 1 only, with 0 being a definite non-occurrence of the event and 1 being definite occurrence of the event. Sample space, S, is the set of all outcomes of an experiment. Statistically, we can establish the definition of probability as follows. If each event in the sample space is equally likely to happen, then the probability of an event A is given by number of occurrences of event A divided by the size of the sample space. Let us understand this with the help of an example. For example, in a single roll of die, the possible outcomes are 6. Say we want to calculate the probability of getting a 2 on a roll. So at a roll, we can get 2 only once, thus the probability will be 1 out of total 6 possible outcomes. Similarly, taking another example of pack of cards, total possible outcomes are 52. At a time, getting a 2 of spade is only once, so event is equal to 1, and probability hence will be 1 by 52. Now let us understand about types of events. There can be a simple event which cannot be broken into further events. Example that we just discussed on previous slide. Compound events are those which are made up of 2 or more simple events. For example, getting a 2 in a pack of cards. There is one more type of event, that is called as complementary event. The complement of event, AA, implies occurrence of everything but A. It can be denoted by this equation. Now, let us understand about the laws of probability. First law is the additive law, which says that the probability of 2 or more events happening together is union of them. So, we have 2 events X and Y. The union of events implies that either X happens, or Y happens, or both happen simultaneously. This can be represented in this equation. Probability of X union Y is equal to probability of X plus probability of Y plus probability of X intersection Y. In this diagram, if we see, there are 2 events X and Y, and they are intersecting as well, which means that both X and Y are occurring simultaneously. This overlap between areas represents the probability of intersection. When both the probabilities of x and y are added, this intersection is included twice, so in the equation we subtract the intersection y once. An example of such events can be probability of getting 2 and probability of getting a spade in a deck of cards. The multiplicative law talks about the intersection of 2 or more events. Like in this Venn diagram, we can see the white highlighted area is the probability of intersection of 2 events A and B. This can be represented in the form of this equation. Probability of A intersection B is equal to probability of A and B. Thus it is equal to probability of A multiplied by probability of B given A has happened. This is also equal to probability of B multiplied by probability of A given B has happened. This conditional probability implies that the probability that B will occur if A has, and similarly, probability that A will occur if B has. In our same example, conditional probability will be probability of getting 2 of spade. We should also note here that the 2 events may be independent, meaning they don't have influence on each other's occurrence. So, what are independent events? As we just saw that independent events have no influence on each other's outcome. Now let us see what is the significance of independent events in multiplicative law. If 2 events are independent, then the conditional probability of B given A has happened will be equal to probability of B. And similar will be the case for probability of A. Thus the multiplicative law will be probability of A intersection B is equal to probability of A into probability of B. If 2 events cannot happen simultaneously, such events are called mutually exclusive events. For example, in a single roll of die, 2 and 6 cannot happen at the same time. The multiplicative law for such events is 0, as there is no intersection. The fundamental counting principle or probability theory says that if one event can occur in A ways, and another event in B ways, then the number of ways 2 events can occur in a sequence is A into B. For example, in a flip of 2 coins, we can get 4 different outcomes, 2 for each. We can make use of permutations and combinations to answer more complex probability questions. Permutation is about selecting without replacements, meaning ordered selection of n different elements. This means, if we have n different objects in a collection, but only want to take r of them, the formula for the number of permutations of n elements taken r at times is npr, where n is number of objects chosen and r is number of positions occupied. For example, 3 model chairs are to be put atop 3 displays on Alex's showroom out of total 6 models selected. Possible permutations would be solved like this. One way can be 6 into 5 into 4, which equals to 120. Alternatively, using equation, 6p3 equals 6 factorial divided by 3 factorial. This also gives the answer as 120. So there are 120 possible permutations to put top 3 display chairs out of total 6 models. The combination of n elements taken r at a time is a subset of the collection of elements. Here order is not important. We can have replacements in such cases. For example, red-blue, or blue-red, both are the same combinations. Number of combinations can be calculated using this equation. For example, if we want to pick 3 models out of total 10, how many combinations are possible? Solving the equation of 10c3, we get 120 as the answer. Remember, here the order is not important. In this lesson we learnt about various basic concepts of probability. We learnt about terms, laws and in brief about permutation and combination. By now we must be able to understand what do we mean by probability and how can the basic probability be calculated, as that has some application in our next lesson which will cover various probability distributions. Here we come to an end to this lesson. Should you need any support, feel free to contact us. Thanks for watching this video, and see you in the next lesson.